กล้องไม่ได้
ทำไมอะคะ
ผมใช้คอม PC อะครับ
แล้วคนอื่นล่ะคะ ที่ไม่เปิดกล้องคืออะไร เปิดกล้องเรียนด้วยนะคะ โอเค teacher
All right, good morning, students. Good morning, everybody.
Good morning. Good morning. Good morning.
How are you guys doing today?
I'm doing.
All right. Okay, just wait for a while. Let all of your friends join so we can start the class today. So right now we have just only 11 students. Just wait for a while and let the rest of your friends join so we can start. All right, so you guys have your textbooks already with you? Okay, very good. Science. Today's subject is science in action. So today we are going to learn about electrical circuit connections, page number 76. Page 76. All right, so let's start. All right, so in our last class, we learned about batteries, right? And the sources of electric. How do we get electricity and electric currents, right? So today, our today's topic is electrical circuit connection, right? So first of all, we are going to learn about electric current measurement, how we can measure the current flow in a circuit, right? So for the measurement of electric current, we use a meter, right? Maybe all of you are familiar. You can see on the picture, right? So this electric device, what we call that, it's actually a meter. So with the help of a meter, we can check that how much is the flow of current in electric circuit. So first of all, in our electric light circuit, the brightness of electric bulb tell us that there is an electric current. Like normally, while the brightness of the bulb, actually it can tell us that this line, the circuit, they have electric current, right? But we cannot measure, we cannot say how much is the flow of electric current. So to find out the measurement of electric current, we have to use this device, a meter. So this device, what we call that? We call that a meter, right? So what is an ammeter? An ammeter is a device used to measure electric current. The unit of current are ampere. So the symbol of that is A under brackets. That's actually the symbol of ampere. And ampere is actually the unit. It's the base unit of current, right? Or the milliamps. So milliamps, the unit, the symbol of that is MA under the bracket, right? You can see MA. That's actually the unit of milliamps, right? So 1 ampere is equal to 1000 milliamps, or you can say 1000 milliamps is equal to 1 ampere. That's how we calculate. That's how we calculate the measurement of electric current, right? In a circuit diagram, the symbol of an ammeter is a underline. It's actually the symbol of, like, if you draw a diagram of an electric circuit, right? So usually we don't write the name, right? We don't write the name, we just write down the symbol. So this symbol, A under circle, right? So this is actually the symbol of ammeter. All right. So here, now I repeat one more time. Electric current measurement. How do we measure the electric current? So with the normal in our electric light circuit, the brightness of the electric bulb, actually they tell us there is electric current, right? While we look to the bulb, right? So if the bulb is flame, right, the brightness of that, they can tell us that there is a flow of electric current, but we can't say how much amount of electric current is flowing in the circuit. So to find out that, we need a device. So the device, what we call that, ammeter, right? So this is actually ammeter. With the help of this electric device, we can measure the flow of current, right? Electric current. And what is the unit? The unit of current is actually ampere, right? And the symbol of ampere is A under brackets. That's actually the symbol of ampere, or you can say milliamps. So milliamps is 1000 ampere is equal to 1 ampere is equal to 1000 milliamps, or you can say 1000 milliamps is equal to 1 ampere. And the symbol of that is MA, right? In electric circuit diagram, while we write down, so it's actually the symbol. And the symbol of the meter is, the symbol of a meter is A under circle, right? This is actually the symbol. All right, students, you understand that? How we can measure the electric current? With the help of a meter, right? And these are the information given to us, the units. All right. So how we can use how we gonna use a meter properly, right? So first of all, what we have to do, we have to make sure when connecting an ammeter to an electric circuit, so the positive electrode of the circuit cell must be connected to the positive terminal of the ammeter. So here, for example, you can see what you have to do while you are connecting ammeter with electric circuit. So what you have to do, you have to make sure that the positive electrode, right, the positive electron, it have to be connected with the positive terminal of ammeter. You cannot connect a positive electrode with the negative terminal of the meter. If you connect that, so it will be damaged, right? So you have to make sure when you are connecting an ammeter to an electric circuit, so the positive electrode of the electric circuit cells must be connected to the positive terminal of the ammeter. So why we do that? This allow current to flow through ammeter by entering at its positive terminal and out from its negative terminal. So if we do so what happened? The flow of the current, actually it goes through the meter entering at the positive terminal, and then it flow out to its negative terminal. So that's actually like entering from the positive, and then from the negative it go out. All right, so it's very important not to connect the ammeter in any other way. For example, connecting positive terminal on the ammeter to negative on the cell, or connecting the ammeter directly to an electrical energy source without any circuit. or without any other electrical equipment connected to the circuit. So as either case will damage ammeter. So you have to make sure, in short, I would like to tell you, whenever you are connecting a meter to the circuit, right? So you have to make sure that the source from which you get the electric current, so the positive electrode, you have to connect to the positive terminal of the electric meter, right? So it actually allow that the electric flow from enter to the meter through the positive and then go out through the terminal negative, right? So if you do so, so the electric flow, it will be going, right? It will be circulate. But if you connect, if you connect the electrode to the electric meter to the negative, right? So what will happen? Actually, the meter, it will be get damaged. It won't work. All right, students, you understand that how you have to connect to the electric ammeter to electric circuit? Students, do you guys understand that how you are going to connect the?
Yes.
Okay, it's very simple. You just have to make sure that the positive electrode, you have to connect with the positive terminal of the meter, right? And the negative electrode, right, you have to connect to the negative terminal of the meter. So the flow of the current, it will be circulate. All right. Okay, so now here, our next topic, the one is series and parallel circuits, right? In our last class, we already learn a little bit about series and parallel circuits. So here we are going to learn in a bit more detail. All right, and we have the diagrams also to help us to understand series circuits, right? So we have two light bulbs, right? We have two light bulbs connected in a long chain from positive electrode to negative electrode of battery. Therefore, if there is a light bulb out, the other one will also burn out. All right, that is because it's not a complete circuit. So here, as you can see in the diagram, right? So we're having the battery, right? And we're having two light bulbs, right? Bulb number 1 and bulb number 2, right? And it's all connected in a long chain, right? From positive, here you can see from positive, one side is actually the positive electrode, the other one negative, right? It's connected in a long chain. So therefore, if the light bulb burn out, the other will also burn out. Like for example, in between these two bulbs, if one bulb will actually burn out, so the other bulb, it will also burn. It won't work. Why? Because this is actually not a complete circuit. Okay, it's not a complete circuit. So connecting light bulbs in series, the circuit flow in a single pathway. So here you can see the diagram is given to you. Like this is actually what we call that it's a single pathway. Like from one side, actually from positive electrode, the current flow and just flow keep continue given to the first bulb, and the flow also continue again. So this series actually, it's a single series, right? It's a single pathway. There is no other pathway. So for example, if one bulb, it burn out, so automatically the other bulb will also burn out. Why? Because this is not a complete circuit, right? So the current flow in a single pathway. So because of that, the brightness of each bulb will decrease if more bulbs added. So as this is actually a single pathway, number one understanding is if one bulb it burn out, so the other will also burn out. Second one is if we add more bulb in this circuit, so the number of bulbs increase, So the flow of the current, it won't go 100% to each bulb. So the brightness of the bulb will also come down because the pathway is only one. Okay, the pathway is only one. So that's why the flow will also come down. So this is actually a series circuit. Okay, now next one is a parallel circuit, right? So a parallel circuit, here we have two light bulbs, but there is more than one path for current to flow. Here you can see we have the same diagram, the same circuit, right? But as you can see, the paths, they are more than one. Here you can see this is the first path, right? And you can see here there's another path, right? So path number 1 and path number 2, right? So here actually the flow of current, actually they have more than one path. So therefore path 1 is line 1 and back to the battery, right? So the path 1 here you can see from the path 1, actually if the flow of current, it flow from this one, from path 1, and then it come down directly back to the battery. This point is actually the battery. Here you can see, right? That's actually, this point is the battery point. So the flow continue with path 1, but in between you can see they're having another path, right? They're having in between another path. So the benefit of this circuit is, if for example the one path on path 1, if one bulb it just burn out, so the second bulb it will still work because they have another path. They have more than one path. So the flow of electric current is there available for the second bulb. So this is actually the benefit of parallel circuit, right? So there is another path in line 2 and back to the batteries. So like you see here, this was path 1 is this one, electric current flow from here, continue, right? And then back to the battery. This is one path. The other path is the electric current flow start from the battery, come here, and then with the help of the second path, come directly back to the battery. So the flow of the electric current is from both paths. Okay, so there is another path. There is another path in the line 2 and back to the battery again. So each individual path is called branch. So each path, what do we call that? We call that branch. All right. Therefore, if there is a light bulb burn out, the other one will still work. It is because the circuit is closed and it is a complete circuit. So this is what I mentioned, students. If, for example, in these bulbs, if one single bulb is actually burned out, so the other one, it will still work. All right. For example, if the first one burn out, the second will still work. Or either if the second bulb burn out, so the first one will also work, because the flow continue, the flow of the current continue. So this is what we call actually a complete circuit. Connecting light bulbs in parallel, the current flow in any pathways, thus the brightness of each bulb will be the same. So that's also another benefit, because the flow of the current, they have more than one path. So that's why if we connect more than one bulb, either 2 or 3 bulbs, right? So the brightness of each bulb, it will be the same, like it won't reduce. There will be no difference. All right, students, you understand that? Parallel circuit. Students, do you guys understand? Yes. Parallel circuit and series circuit?
Yes. Yes.
Okay. All right. So if you guys understand, now I'm gonna move towards some of the questions. Okay. and you have to answer to me. All right, so here you can see, here we're having some of the learning activity. Okay, we're having learning activity. So we have three different circuits, circuit A, B, and C, right? So you have to consider the picture and then answer the questions, all right? So question number 1, which circuit glow the light bulb? What do you think? Which circuit connection glows the light bulb? Who can answer me? Look at the, first of all, look at the circuit carefully, right? Look at the connections. Positive electrode, negative, connected with positive and negative. Then in the B, you can see positive, right? Negative, and then negative have connection, right? Connected with each other. And the other one is the parallel one, the C one, number C. So what do you think in these three circuits, which circuit connection will glow the light bulb? Students, anyone can answer me?
A.
Again, a little bit louder, please.
A.
A, that is the correct answer. Okay, another one, only A or anyone, the other two circuits as well?
C. I think
Exactly, that is the correct answer, A and C. So actually, if you take a look closely, to each circuit, so the connection, one is the connection of each batteries. You can see here, they're having plus, minus, and then plus, minus. So as you can see here, the join here is accurate, plus, minus. So the flow of the current, it will circulate. So B is not there. Why? Because as you can see here, while two batteries, they are connected, so both electrode side, they are minus. So that's actually wrong. So B, actually, there will be no glow of in this circuit, actually, there will be no flow. The flow of the current will be break. The current won't pass through, right? So A and C, circuit A and C will glow the light bulb. All right, now question number 2. Which circuit connection glow the light bulb brightest? What do you think? In all these three circuits, which circuit that will glow the light bulb more brighter or the brightest? Anyone can answer me, students?
Students,
It is.
answer please.
It is B.
B, I guess that's not the correct answer, because as you can see here, the circuit is not correct. So B is not correct. So as we already learned, the flow of the current, it will be more brighter in A, in circuit A. So A is the correct circuit. All right, now question number 3. Which circuit connection is series circuit? Now take a look closely to all these three circuits and tell me which circuit connection is series circuit. We just learn about series circuit and parallel circuit. So among these three, which one is series circuit? Take a look here. It's a series. Look at the batteries. The one is parallel, other one is series. Number one, circuit connection A. That's a series circuit. So the answer is A. All right, now question number 2, we have given two different circuits, connections, right? A and B. You have to look closely to each connection, each circuit connection, right? And then answer the questions. So question number 1, if a light bulb in A circuit burn out, what will happen and why? Anyone can answer me, students? In the circuit A, if one light burn out, so then what will happen? And why will happen that?
Students,
Another one will burn out. I mean,
Exactly. That is a correct answer. A, just before we learn, if if one bulb actually a burn out, so the flow of the current, because of the flow of the current, so the answer is another bulb will burn out as well. Why? Because the electric current cannot flow to the next light bulb. So actually the flow of electric current, it will break. Just before we learn, right? So if, for example, in the circuit A first bulb, it actually burn out, so the other one, it will also burn, because the flow, as you can see here, this is just a one series. They have only one pathway, a single pathway. So that's why the flow of the electric current, it will be disrupted, right? So the answer is another light bulb will burn out as well, because the electric current cannot flow to the next light bulb. All right, question number 2 regarding circuit B. Okay, if a light bulb in B circuit burn out, what will happen and why? Anyone can answer me, students?
Upo, you can answer. Okay.
Remember, just before I told you, students, they have in circuit A is single pathway. In circuit B, they have more than one pathway. So what will happen? Have your answer, please.
There will be one light bulb shut down, but the others will still glow.
Exactly, that is a correct answer. So if a single bulb actually burn out, the rest of the bulbs, it will still be still working. Why? Because other two light bulbs still light up, because the electric current can flow to them. Here you can see, for example, if a single light actually it burn out, so the other two, it will still work. Why? Because here you can see we have more than one pathway of the electric current where it flow. You can see here. So if first one is damaged, right? So the other two, it will still work. The electric current, it will flow in the other two pathways. So that's why the rest of the two bulbs, it will still light up, because of it's a complete circuit. Okay, very good. All right, so these are some of the questions regarding the series circuit and parallel circuit. So you guys already write down the answers in your books, students? Students, did you write down already the answer in your books?
Are you done, students?
I
yes.
finished.
Someone, teacher.
Okay, all right. I just give you a minute or so, and then we're gonna move to the third. Question number 3 then. All right. If any of the students didn't write, so don't worry. Later on, you can watch the video and you can write down. Okay, now come to question number 3. So here we have another 2 circuits. Okay, circuit A, right? Connection A and circuit B, right? So here we have these 2 circuits. So one you can see here, this is what we have to find. We have to find the differences and similarities in both circuit. Okay, so we have to compare the similarities and differences between 2 circuits. Okay, circuit A and B. Any students can tell me the differences first. What are the differences between the both circuits? Anyone can tell me? You remember the name of these circuits, students?
May I go to the toilet, please?
All right.
Okay.
All right, students. Anyone can tell me what are the differences between circuit A and circuit B?
Circuit A is a series and circuit B is parallel.
Excellent. That is a correct answer. Circuit A is a series circuit and circuit B is parallel circuit. Okay, so these are actually the differences. First one is series circuit, right? Second one is B is parallel circuit. Okay, students, now come to the similarities. What do you think? What are the similarities between circuit A and circuit B? Can anyone tell me? Just take a close look to each circuit, right? And let me know about the similarities. All right, one, I'm gonna tell you that both are actually closed circuit. Okay, so both are the, as you can see here, they're all closed circuit. Okay, this is one similarity. Okay, number 2, anyone can tell me? It's very simple. What are similar?
Don't keep quiet, students. Answer, please.
Okay, let me help you. How many bulbs are in circuit A?
3.
How about circuit B?
3. 3.
So they are similar or not?
Similar.
Very
Yes.
good. So other similarity is circuit A have 3 bulbs and circuit B also have 3 bulbs. Okay, now one more similarity. I already helped you for 2. How about the electric current? It comes from where? Is it similar or not?
It comes from battery.
Very good. How many batteries are there?
1 each.
1 each. So that's the that's the other similarity. So number 2, there is only 1 battery. Okay, here you can see in each circuit they have only 1 battery. So that's the similarity between both circuit. Second one, each circuit they have 3 bulbs, right? So that's the third similarity between these circuits. Okay, excellent job. All right. Okay, students, you already write down in your books. And then you have a little bit more work. Okay, so I already just draw for you. Here we have actually 5 different circuits. Okay, as you can see here on your screen, we have here 5 different circuits. So what you have to do, you have to draw the diagram. You have to draw the diagram of each circuit. Okay, here I just give you a little bit hint. I already draw for you here. These are all the diagrams. Okay, I already write down for you. So here, like a circuit number 1, point 1, here you can see these both points, actually they're having the bulbs, bulb 1 and bulb 2. All right, now at this point in the circuit, this actually the battery attached. So battery, one side is plus, other side is minus, right? Now what is this point? This point is the switch, on off, on off. Okay, so this is the diagram of circuit 4.1. Okay, and 4.2, as you can see here, they have here 2 connections, right? I'm sorry, they have 2 light bulbs. So these 2 points actually, they represent the 2 light bulbs. All right, and that's the electrorod, right? They're connecting with the light bulbs. So similar here, this point, it is for battery. And here, right at the bottom, this point is actually for the switch. Okay, it's for the switch, on and off. Similar 4.3 circuit, as you can see here, we have 2 bulbs. So they have more than one pathway. Okay, so as you can see here, they have more than one pathway and they have 2 bulbs connected. Okay, and right here is the battery point from where the electric current flow. All right, similar connection number 4, right on top here, you can see here is a battery point, right? And parallel to the battery point, here we have the switch, on and off. Both on the right side and on the left side, they have 2 points where we connected 2 bulbs. And the last one, the last circuit here, you can see that's the series circuit, right? So here we have